Okay, guys, let's review some basic high school level math here. So on this one right here, we're asked to add these two rational expressions. Notice that the denominators are different. So what we need to do is make a common denominator, which in our case is simply just to times the two denominators together. So I'm showing all the math like you would see in the textbook. But anyways, since this one's x minus 3, we need to add to it the x plus 3 denominator, which means we're technically going to times by x plus 3. Now here we have to do our distributive property, so that's why it's 9x plus 27. Okay? The right fraction here, notice we have the x plus 3. We need this x minus 3. So we're going to times top and bottom by x minus 3. And here we're going to distribute again. And we're going to get 5x minus 15. So our final answer is going to be 9x plus 5x, which is 14x. 27 plus negative 15 would be 12 over our x minus 3 times x plus 3. And this would be our correct answer. Now, sometimes they'll have you multiply the denominator together. Hopefully you recognize this is a difference of two squareds. So you're going to say x squared minus 9. Now, what I'm hoping is you pause it, you take notes on this, make sure you understand each and every step I did. And then hopefully you can repeat that tomorrow or the next day on the online assessment. Okay? All right, let's look at this one here. They're asking for the x-intercepts. Well, what you need to understand, hopefully, is that means that y here must be 0. So if y is 0, how am I going to make this 0? Well, 3x minus 7 must simply be 0. The squared we can kind of ignore because 0 squared, of course, is still 0. Solving this, I'm going to add 7. So 3x equals 7. Dividing by 3. X is simply 7/3. So again, I hope you pause, take notes, study it just a little bit. It'll only take you a few minutes. But make sure you understand that x-intercepts mean y has got to be 0. And then you solve for 0. Okay, let's take a look at this one. Now this one's kind of a special case. So notice we have a squared here. So to get rid of the square, we square root both sides. Now on the left side here, the square root gets rid of the square, and we're just left with x minus 6 equal to, on the right side, we have to realize that technically you can't do a square root of a negative unless we use complex numbers, and that's what we're going to do. We know that the square root of 16 is 4, and it's going to be a 4i because of the negative here. One thing you may have forgotten is when you do square roots, you have a positive and a negative answer. So long story short, I'm going to add 6 to both sides, and x is simply going to equal to 6 plus 4i and 6 minus 4i. So you get two answers in one. Remember, complex numbers always comes in pairs because of the plus and minus relationship from a square root. Okay, now this is a cool one. It's one of my favorite ones, even though it may have confused you. They say that angle B is congruent to angle C. So they're saying that this angle here is congruent to this angle here. Well, one of the things you should have learned in IM2, hopefully, or IM1, or IM3, maybe not. Some teachers may not have taught you this, But whenever I have two angles the same, I know that the two sides here have to be the same. So therefore, if this is x plus 2, this is x plus 2. And they're saying here, we want the perimeter to be 25. So what's the perimeter? I'm just going to add up all three sides. See how I added this plus this plus this? And that's got to be 25. The perimeter, remember guys, is going around the shape. It's the distance around the shape. So doing a little algebra here, you should agree it's 3x plus 4 equal to 25. That means I'm going to minus 4. And if 3x is 21, that means x must be 7. Now they're going to ask for just one side, but let's find all three sides. So first of all, we ought to realize that this side is 7. This side is 9, because 7 plus 2 is 9. And this side is also 9. Notice these sides have to be the same because these two angles are the same. The official name, by the way, it's called an isosceles triangle. Isosceles triangles have two angles the same, and therefore two sides will be the same. All right, let's move on here. So on this one here, I hope you notice they're asking us to factor. Well, I hope you notice that all the coefficients in this constant here are all even. So the first thing I must do is divide by 2. I factored out a 2. I divided each one by 2. That's right there. Okay. And now, this middle part here, we can do a simple x on. Okay, that's a y4 there. So we're going to pretend it's y squared and y. Okay. And we're going to do an x, and we're going to take the 8 as our product, the minus 6 as our sum. And negative 2 times negative 4 is 8. And negative 2 and negative 4 is negative 6. So now we know we have 2 parentheses y squared minus 2, y squared minus 4. The reason why I did these y squareds here is because of the y4 and the y squared in the middle. Now, normally that would be our answer. However, I hope you notice right here, this is a difference of 2 squares. So our final result is the 2, the y squared minus 2, and this is y minus 2 and y plus 2. And so technically we would say we have 1, 2, 3 factors, although this one's square. It's really 2 and 1. And of course the 2 is our GCF. But that's the complete factored form. Okay, so this one's an interesting one. If they give us some generic function, I made this up of course, 3a to the x power, and they tell us that a is greater than 1, I hope you realize that that would make it a growth function. If a here is less than 1, i.e., well, let's say it's less than 1 and greater than 0, we want to keep it positive, then we know it's a fraction, which means it's a decay function, which you should have learned in IM1 as well as IM3, among other classes. Okay, but how do we do the graph? Well, I recommend you just do a couple of points until you see a pattern. For example, let's first of all, let's pretend we know that a is greater than 1. Let's do greater than 1 first. I'll do it in red. So greater than 1 will be in red. Okay, so what you would do as a simple trick is just make sure you pick a number that's easy, that's greater than 1. How about 2? So our function is 3 times 2 to the x. 3 times 2 to the x. What would that look like? Well, when x is 0, anything to 0 power is 1, I would get 3 times 1, which is 3. So 0 is 3. How about when x is 1 there? I would get 3 times 2, which is 6. So 1 would be 6. As you can see, it's just going to skyrocket up and come down this way. And there is basically your growth function. What happens if a is less than 1? It's just going to go in the opposite direction. So, in other words, it's going to go like this. So, hopefully you will study those functions. Again, I could simulate. I'll do blue for less than 1. Let's say a is 1/2. How about 3 times 1/2 to the x? So you notice when I plug in 0, I still will get 3. So let me graph it better here. So I would still get 0, 3. But what happens when it's 1? I would get 1, and then 3 times 1/2 would be 1.5. So you can see it's going to shoot down like this, actually, and go up to infinity like that. So that originally was a little bit off. But hopefully you kind of will study and understand that. And that's as far as this video is going to go. Please study each of these individual problems. I promise you, you will see a version sort of like this here on your actual assessment. And I expect you, if you study this, you should be able to figure them out.